In this video, we will learn about electric potential difference. To move a charge from one point to another, we require some potential difference, or we can simply say that some work has to be necessarily done. That is, some work has to be necessarily done. So let us consider 2 points. That are, first point is A and the second point is B. And we have a charge of magnitude Q that we need to move from A to B. And the work done in this process is WAB. So the formal definition of potential difference is the potential difference between two given points, say points A and B in an electric circuit, is defined as the amount of work to be done in order to move a unit positive charge from one point to another. So the potential difference V or VAB can be represented as potential at A, that is VA, minus potential at B, that is VB, or we can simply write it as potential difference is equal to work done in moving the charge from A to B, that is WAB, divided by the total charge Q. Potential difference is usually denoted symbolically by the letter V. Let us now see the SI unit of potential difference. So the SI unit of potential difference is volt, and we have seen earlier that the potential difference is represented by the letter V. Next point is that we have seen the formula of potential difference as V is equal to work done in moving the charge divided by the total charge. So in which case the potential difference is 1 volt. 1 volt. It is simple. When the work done is 1 joule and the charge that is displaced is 1 coulomb. So in this case, the potential difference comes out to be 1 volt. So that is what is written here. Potential difference between 2 points is said to be 1 volt if a work of 1 joule is to be done to move 1 coulomb of charge from one point to another. So the potential difference 1 volt is equal to 1 joule divided by 1 coulomb, and 1 volt can be represented as 1 joule coulomb inverse. Also note that electric potential difference is a scalar quantity. Flow of electric charge and potential difference. As we have seen earlier, the electric charges do not move by themselves. They require some work to be done, or you can simply say that they require potential difference. Let us consider two analogies to make this concept clear. The first analogy is of the flowing of water in a tube. So if we have a horizontal tube like this, both the ends are at the same level. First end is A and the second end is B. Do you think the water will flow by itself? No, the water will not flow by itself, and the water will remain in the tube only. Now let us consider a tube in which the end A is at a higher level and the end B is at the lower level. Now the water will flow, and the water will flow from A to B. Now let us consider two beakers. The first beaker is A and the second beaker is B, and they both are connected like this. And initially the channel is blocked by a stop valve. The water in beaker A is at the higher level and the water in beaker B is at a lower level compared to the water in beaker A. When this valve is removed, as A is at the higher pressure side, the water from A will move towards the beaker B, and it will move till the level of the water becomes same in both the beakers, like this. Since the pressure becomes equal, now the water will not further move. Thus, for the flow of water through a tube, a pressure difference must be maintained between its two ends, and water flows from higher pressure side to lower pressure side. Now we will be discussing the second analogy, which is based on thermal conduction. Let us consider two objects. The first object is maintained at a temperature T1 and the second object is maintained at a temperature T2, and they both are joined. Now in the first case, if T1 is equal to T2, there will be no heat flow. no heat flow as both the temperatures are equal. But if one object is hotter, now let us say T2 is greater than T1. Now there will be heat flow. And the heat flow will be in the direction from hotter object to the colder object, or we can say that the heat will flow from the object at higher temperature to the object at lower temperature. Thus, for the flow of heat, we must maintain a temperature difference, and the heat flows from higher temperature to lower temperature. Now similarly, based on these two analogies, we have the flow of electric charge. So for the flow of electric charge, we must maintain a difference of electric pressure, and this electric pressure is what we are calling potential difference. So a potential difference is important for maintaining, or you can say, the current flow, and the positive charge or the conventional current flows from higher potential side to the lower potential side. Production of potential difference. We have already seen a cell which converts chemical energy into electrical energy. When these chemical reactions takes place, we have a potential difference between the two terminals of the cell, and thus the simplest method to produce a potential difference is by the use of a cell or a battery. This is the reason why a cell acts as a source of direct current in an electric circuit. In our day-to-day usage, we use dry cells which have a potential difference of 1.5 volts. If we use a combination, that is, if we use 2 or 3 cells, it can produce a potential difference of 3 or 4.5 volts. In our cars, we use a combination of lead accumulator battery. Each lead accumulator produces a potential difference of slightly more than 2 volts. So thus a car battery runs on a potential difference of nearly 12 volts. Measurement of potential difference. Voltmeter is a device which is used to measure potential difference across 2 points. In this diagram, we can see a voltmeter in which there is a needle which points towards the value of the voltage. In this particular case, the range of the voltmeter is 12 volts and the least count of the voltmeter is 0.4 volts. A voltmeter is always connected in parallel across the points. The potential difference needs to be measured. In this diagram, you can see that the voltmeter is connected in parallel to A and B. Additionally, the resistance of the voltmeter should be extremely high so that it draws negligible current from the circuit. That is why resistance of an ideal voltmeter is taken to be infinite. Let us now discuss the differences between an ammeter and a voltmeter. The first difference is fairly simple. An ammeter measures electric current, whereas a voltmeter measures potential difference. The resistance of an ammeter is extremely small so that it does not affect the current flowing in the circuit, whereas the resistance of a voltmeter is extremely high so that it does not draw current from the circuit. An ammeter is always connected in series with the electric circuit, whereas the voltmeter is always connected in parallel. I hope this topic is clear to you. Thank you.